some nice scenery to begin. But yeah, we're looking at one more operation with signed numbers, division. Okay, we looked at multiplying two signed numbers last time, and there's a simple rule, much simpler than adding signed numbers. So when you're multiplying two signed numbers, just remember if they have the same sign, the answer is positive, and if they have two different signs, the answer is negative. Okay, and you just multiply the two absolute values to get the number part. Okay, so the good news is that the rule for dividing two signed numbers is the same. Here we're assuming there's no remainder, just to keep it reasonable. Okay, so if you divide two signed numbers, divide their absolute values to get the number part, and then is the answer positive or negative? Well, if the two numbers you're dividing have the same sign, the answer is positive again, and if they have different signs, the answer is negative. And so the reason the rules for signs are the same, it's because multiplication and division, they're opposite or inverse operations. Let's see an example. So example 1, here we have negative 30 divided by 6. There's actually two ways to do this question, but let's, we could think of parentheses around this. So think of this as negative 30, a negative number divided by 6. Well, if you divide the absolute values, so 30 divided by 6 is 5. And then thinking of these, this is negative and this is positive. So we have two different signs, so the answer is negative. Okay, so negative 30 divided by 6 is equal to negative 5. If you multiply by 6, okay, so multiply both sides by 6, so negative 5 times 6 gets you back to negative 30. Okay, so if you divide a number and then multiply by that same number, you get back to the original number. Okay, so you can use that idea to show that these the rules for multiplying and dividing, it's the same. So maybe this wasn't a good first example. I mean, another way to think of this, so maybe more correctly, you could think of this as 30 divided by 6, and this minus out front means the opposite of this. Okay, so that's the opposite of 5, so that's negative 5. Okay, so either way, it's negative 5. Example 2, this one's clearer. So this is definitely negative 15 divided by negative 3. So divide the absolute values, you get 5. And then since these two numbers have the same sign, both negative, then the answer is positive, so positive 5. Okay, so it's always true. A negative divided by a negative is always positive. Okay, yeah, it might seem a little strange, but that's always true. Here's an example, like a word just written in words. Divide 28 by negative 7. Okay, so in terms of division, that looks like this. 28 divided by negative 7. Yeah, you need parentheses here. For the absolute values, 28 divided by 7 is 4. And these two numbers have different signs, so the answer is negative 4. Okay, so we gave this question in words. In notation, it looks like this. It could also look like this. So this forward slash, I guess this is another symbol for division. This means division. And as we'll start looking in the next section, fractions mean division too. So this fraction bar also represents division. Okay, so these two quantities are equal to negative 4. Example 4, what is 0 divided by negative 13? Okay, we have to be careful with zeros, so, but yeah, just remember 0 divided by any number is 0. Okay, so nothing fits into 0, so this goes in 0 times. Yeah, 0 divided by any number except 0. So 0 divided by 0 is undefined, but 0 divided by anything else, negative 13, 0 divided by 106, that'll be 0. And yeah, just to emphasize this, so yeah, a negative number divided by a negative number is always positive. Okay, so did we cover everything in this section? Yeah, so this is the same rule. Yep. Okay, if you're dividing two numbers with the same sign, the answer is positive. Different signs, the answer is negative. So here, positive divided by a negative is negative. Different signs. And yet, so here it is in a box, some formulas. So 0 divided by any non-zero sign number is always 0. And yeah, if you can't divide by 0, so this is always undefined. Okay, anything divided by 0 is undefined, or in other words, you can't divide by 0. Okay, back to multiplication, powers of sign numbers. Yeah, these can be surprisingly tricky. Okay, so powers. So we're talking about this kind of situation. So this is 2 to the power 3. The number on the bottom, that's the base. The number up here is the power or the exponent. 2 to the power 3, yeah, it's not 6. It really means 2 times 2 times 2. So again, multiplying 3 2's together, 2 times 2 is 4, and 4 times 2 is 8. Okay, so here the base was 2, the power was 3. And for any of these types of questions, yeah, you have to be very careful. So always take a moment to work out what the base is. Okay, so these are the two cases where people run into trouble. Yeah, it's very easy to make a mistake. So here in A, we have the quantity -5 to the power 2. And here we have, this looks slightly different. We just have -5 to the power 2. Okay, so the parentheses here are telling us that the base on this one is -5. Okay, this one has no parentheses, so the base here is just the 5, if you can still see it. Okay, so the parentheses are showing us the difference between these two questions. Here the base is -5. So in A, this means -5 squared, so -5 times -5. They have the same sign, so the answer is positive 25. In B, the base is just 5. So it's really 5 times 5. But don't forget about that minus out front. So this is really, yeah, this minus here, it really means the opposite. So we need the opposite of 25, just means switch the sign, so that's -25. Okay, yeah, so it's a bit tricky. So this, if you just kind of read it right in your mind, so this means -5 times -5, that's 25. You could read this as the opposite of 5 squared, so that's the opposite of 25. Okay, another one of those. So example 1, -3 in parentheses cubed, so -3 to the 3rd power. Okay, so just check. Yeah, we have parentheses, so that's telling us that the base is the whole thing, -3. So this does mean -3 times -3 times -3. If you do the first two, you get positive 9. They have the same sign. And then 9 times -3. Now it's two numbers with different signs, so we get -27. Okay, everybody follow that? So the base here was -3, so that's what we're multiplying together, 3 of those, and then just going from left to right, we get -27. Example 2, and now it's -2 to the power 6, so a bigger exponent. Yeah, we still have parentheses, so the base is the whole thing, -2. So we need to multiply 6 negative 2's together. And yeah, a nice way to do it is do the first two. Negative 2 times negative 2 is 4. Do the third and the fourth. You also get 4. And the last two you get 4. So yeah, if you're multiplying a bunch of things together, multiplication's associative and commutative, so you can do the multiplications in any order, whichever is the most convenient. Yeah, I could also have done, if you multiply three of these guys together, that would be negative 8. This would also be negative 8. Negative 8 times negative 8 is 64. So any way you do it, you'll get the same answer. So negative 2 to the power 6 is 64. And yeah, we can compare that with the next example, negative 2 to the power 6. Yeah, it's better to read this as the opposite of 2 to the power 6, because now the base is 2. So 2 to the power 6, we'll do that first. That's the same number, 64. 2 times 2 times 2 times 2 times 2, 6 of them. And then we need the opposite of that number. So the opposite of 64 is negative 64. Okay, so again, I hope you're seeing the difference. Yeah, these parentheses are important. They're telling you what the base is. If you don't see the parentheses, then the base is just the positive part. So yeah, so maybe there could be better notation for this, but that's just the way it works. Okay, so we did see last time, looking at multiplication of signed numbers, that if you have a product where there are an even number of negative factors, then the product will be positive. The product will be negative if you have an odd number of negative factors. Okay, so odd and even, just because if you multiply two negatives, you get a positive. So every pair of negatives, the signs cancel out. So it just depends on if you have an even number, all the signs cancel, you're positive. If you have an odd number, then all but one of the signs cancel. So you still have a negative sign, so the answer is negative. All right, so working out the sign of the power of a negative number is easy. If you have an even power of a negative number, that'll always be positive. If you have an odd power of a negative number, that will always be negative. So yeah, so that's kind of a shortcut. Yeah, we can go back to our examples. So yeah, so here we have an odd, back in example 1, we have an odd power of a negative number. So that the answer has to be negative. Yeah, we saw that. Negative 27. In example 2, we have an even power. 6 is even, so an even power of a negative number. So the answer has to be positive. Yeah, and that makes sense. So again, you could think of the signs canceling in pairs. No odd parts left over, so the answer is positive. Here, two of the signs canceled, but there was still one negative left over, so the answer was negative. Yeah, this is a bit different. So this is really a positive number to the so a positive number to any power is always going to be positive, but then we have a minus out front, so that makes the whole thing negative. Okay, so we can't use the rule here. We don't have a power of a negative number, so this rule is only for powers of negatives. So, example 4, negative 12 to this power. So what is this? 10,001. So is this number positive or negative? Well, this is a very big number. There's no, if you multiply 12 by itself this many times, that's going to be too big to handle, but we can work out the sign. So is the power odd or even? Well, any number that ends in an odd number is always odd. So this is an odd power, so that tells us that the answer, whatever big number it is, it's going to be a big negative number. Okay, if it was negative 12 to the power 10,002, then that would be a positive number. Okay, this tricky looking example 5. So maybe a good way to read it, it's the opposite of negative 2 cubed. Okay, so the base here is negative 2. Negative 2 cubed. So yeah, you can see it's 2 cubed is 8. We have an odd power of a negative, so it's the answer is negative, so negative 8. Okay, but we can't, we're not finished here. We still have to deal with that minus sign. Okay, so far we've just worked out this piece, but there's still a minus out front, and that minus is just saying we want the opposite of what's in here. Okay, so you can write it like this. So we need the opposite of that negative 8. The opposite just means switch the sign. So switch the sign on negative 8, you get 8. Okay, I hope you're getting used to these. So again, this is the opposite. If you read it, the opposite of negative 2 cubed. Negative 2 cubed is negative 8. So we need the opposite of negative 8. That's positive 8. Okay, how many more of these are there? Example 6. Yeah, just trying to see all the things that can happen that might trip you up. Here we have the opposite of negative 3 to the power 4. Okay, so first we'll work out what's in these parentheses. Yeah, the difference here is the base is 3 this time. So it's not negative 3 in parentheses to the power 4, it's just negative 3 to the power 4. So the base is 3. If you remember, 3 to the power 4, 3 times 3 times 3 times 3. You could think of that as 9 times 9. That's 81. Okay, so this piece is 81. We need the opposite of that. So that's negative 81. And there's another minus. So we need the opposite of that. So the opposite of negative 81, we're back to 81. Yeah, so just, don't make sure you deal with any minus signs. So this basic question is 3 to the power of 4, that's 81. And we want the opposite of that, negative 81. And then we want the opposite of that, so we're back to positive 81. All right, so every time you have a minus out front, it just means switch the sign. Example 7, we have negative 1,324 to the power 0. Okay, so the base here is this negative number. But yeah, then don't forget our rule, anything to the power 0 equals 1. So yeah, it doesn't matter if the base is positive or negative. Any base to the power 0 equals 1. Well, any base except 0. So 0 to the power 0 is undefined, but anything else to the power 0 is defined to be 1. Okay, I think just a couple more examples. Here we have negative 1 to the power 300. Okay, so for this we can go back to our rule. Don't forget, an even power of a negative number is positive, an odd power of a negative is negative. So here we have an even power of a negative number, so the answer must be positive, since 300 is even. If you multiply a bunch of ones together, so just look at the absolute values, multiplying ones, you always get 1. Okay, so the number is 1, and since 300 is even, we take it with a positive sign. So the answer is just 1. Okay, example 9. Okay, in this example we have a negative 16 to the power 0. So what is the base here? There's no parentheses around the negative 16, so the base is just 16. 16 to the power 0 is 1. So it's like we have this situation. 16 to the power 0 is 1, and then the opposite of that is negative 1. Alright, so this is another this tricky case. If it was negative 16 in parentheses to the power 0, the answer would be 1, but no parentheses here, so it's just 16 to the power 0, and then the opposite of that. Okay, in this section, yep. Powers of negative numbers, yeah, it just depends on if the exponent is odd or even. And then again, yeah, looking at this tricky case. So here, again, the quantity -3 to the power 2. So if you have parentheses, that means the base is -3. So the answer is 9. Here the base is just 3. So it's really 3 squared, the opposite of 9. And yeah, here anything to the power 0 is 1. It doesn't matter if n is positive or negative, just n can't be 0. Yeah, any powers of 0, yeah, that's always 0. And the last section in chapter 2, looking at square roots now and sign numbers. Yeah, so we've looked at all the operations, powers, so the last thing is these square roots. All right, yeah, we've already looked at square roots just for positive numbers. So remember, if you, for example, taking 3, so 3 squared, that's 3 times 3 is 9. And square roots, that's just the opposite operation. So you square 3 and get 9. The square root of 9 is 3. Okay, so for square roots, you're looking for numbers so that when you square them, you get the original number. Okay, one thing we didn't mention before was that, for example, here 9 has another square root. Okay, so there's another number that you can square to get 9. That's -3. So just the same number, but make it negative. So -3 squared is, so a negative times a negative is positive. Okay, so every number like 9, every positive number, in fact, has 2 square roots. One positive and one negative. Yeah, the positive square root, that's sometimes called the principal square root. So for example, 5 and -5, these two numbers are both square roots of 25. What about square roots of 0? Well, yeah, 0 just has one square root itself, so 0 times 0 is equal to 0. -0 is the same number, that's still 0. Okay, then it gets confusing. So how about square roots of negative numbers? So for example, what are the square roots of -16? Okay, so I'm putting a question mark here. So we're trying to think of a number so that when you square it, when you multiply it by itself, you get -16. So what's the answer? Well, if you try -4, well, -4 times -4 is +16. So that doesn't work. If you do 4 times -4, well, it has to be the same number. We just want to be squaring, so we're looking for one number, so when you square it, you get -16. And in fact, there's no number that works. So if you just look at the number line, basically your options are 4 and -4, and they don't work. if you square a number on the number line, if you multiply any number by itself, you're always going to get something positive, so there's no way to get a negative. Okay, so we're saying that negative numbers do not have square roots. Or I guess we'll say square roots of negative numbers are undefined. Okay, so that's what we're saying for this course. Yeah, there is a way to get square roots of negative numbers, but you have to go outside our real number system. Okay, so just working on the number line, it's undefined. Okay, so this is our radical symbol that we met before. Yeah, so this radical symbol, we use it for square roots. We've seen a kind of a problem up here where numbers, positive numbers anyway, have 2 square roots. So the idea is that this radical symbol, it always means the positive square root. Okay, so when you see radical 9, that means find the positive number so that when you square it, you get 9. So the answer is 3. What if you want the other square root? If you want the negative square root, well, just put a minus in front of the radical. So this means the opposite. So this is just the opposite of that positive square root. That's negative 3. Okay, so this. Okay, yeah, I know it is confusing, but this is how we're handling the positive and negative square roots of numbers. Just put a minus out front of the radical to get the negative square root. Okay, so example 1 here. So if we're looking at square roots of the number 100, so radical 100, that means the positive square root. That's 10. Yeah, 10 squared is equal to 100. And then this notation with a minus out front, so minus radical 100, that means negative 10. Okay, if you square this guy, you also get 100. Yeah, so yeah, I see so many mistakes. People working with square roots. All right, so yeah, just to try to avoid these mistakes, yeah. So this is the square root of 100. Yeah, it's not 50. Okay, dividing by 2 doesn't work. Yeah, this is, I was seeing this in the homework already. The square root of 100 is equal to 10 times 10. No. 10 times 10 equals 100, but the square root of 100 is just 10 is the answer. So not 10 times 10. And once you've worked out the square root, you don't need the radical symbol anymore. So the square root of 100 is not equal to the square root of 10. It's just plain 10. So don't do that either. And yeah, I was seeing this in the homework as well. I think people confusing the radical symbol with the long division symbol. Yeah, so don't. If you write this, then I know you're getting confused between radicals and long division. Okay, so a couple more examples to finish. So here we have a minus radical 144. Okay, so this means we're looking for the negative square root of 144. Okay, so yeah, 12 squared is 144. You can check. So the answer here is negative 12. And what happens if we put that negative sign inside? Do we get the same answer? No, so this is what we were saying before. So for us, square roots of negative numbers are always undefined. So just write undefined. Okay, yeah, so yeah, we're definitely seeing in this section that when you combine square roots with negatives, it gets confusing. So if the negative sign's outside the radical, that's okay, but if it's inside, then since you can't square anything and get a negative, this will be undefined. Okay, it's positive and negative roots. And undefined if you have a negative. Okay, so I think that covers chapter 2, so we'll start looking at fractions next. Okay.